Hello all and welcome back to my channel JS Lab. So today we are going to see how to use SymPy and NumPy in order to solve polynomial equations. In today's video, I'll explain with an example of a cubic polynomial equation and a quadratic equation. And in the coming video, I'll explain how you can create a general polynomial Python program so that you can you can decide the degree of freedom and how to find the solution. So first of all, you can install SymPy and NumPy. Then I'm going to, this is the equation that I'm going to trying to solve. So it's a polynomial with x cube. So x cube minus 6x square plus 11x minus 6. So that's the example that I'm going to take. Okay, so in order to that, first you need to import the, first we are going to solve using SymPy function, SymPy module. So import SymPy as SP. So first you need to define the variable. So x is the variable, sp dot symbols as x. Now you need to define the polynomial equation. So it's x power 3 6 x power 2 plus 11x minus 6. So I created a new variable called polynomial, introduce this. Then you need to solve it. So the solution will be sp the SymPy dot solve and the polynomial, the variable created, comma the symbol x. Now it will this will print the results, the roots of the equation. So let's try after run. Okay, so I run the program. Yeah, the symbolic solutions are 1 2 and 3. Let's try the same equation with NumPy. So you need to import the NumPy as NP. You need to define the coefficients of the polynomial. So the same example, but the coefficients are, for the x raised to 3 it's 1, is x raised to 2 it's minus 6, x it is 11, and the last variable is minus 6. So coefficients equals inside square bracket 1 comma minus 6 comma 11 comma minus 6. In order to find the roots, so roots equals np dot roots and the variable is coefficients, and this will print the roots. So let's try running the code. So you can see the same roots 3 2 and 1. Yeah. So that's how you can that's where you can solve an equation, polynomial equation, using SymPy and NumPy. Let's go to one more example. Let's take a quadratic equation and solve using SymPy. Same thing, you need to import SymPy as SP. The same, we are introducing a, say, x as a simple or the unknown, and we give quadratic as x square minus 5x plus 6, and solutions equals sp dot solve the variable which is quadratic and x the symbol. Then it will print the results as 2 and 3. We can solve the same equation using NumPy. So import NumPy as NP. The coefficients are 1 minus 5 and 6. You know that, right? So x square coefficient is 1, x is minus 5, and the last one is 6. And in order to find the roots, roots equals np dot roots and the coefficients. This will print the results. Let's try. Yeah, 3 2, we got the same results. So this is how you can use the Python code to solve polynomial equations, finding the roots of polynomial equations. So you can try with other examples as well. So in one of the coming video, I'll explain how to create a general polynomial function so that you can decide what degree and what are the coefficients, etc. Okay, thanks for watching. See you.